Jeez, man, I haven't been uploading in a while. But thank you so much, Clocks, for asking this question. And yeah, so I decided to upload a video. So if you have videos or you have questions that you're struggling with, maths question that you're struggling with for any grade, feel free to text me on my platforms, whether TikTok or Facebook or YouTube. Let me know. Post your question like Clocky did. And yeah, so I'll respond with your video. So thank you so much, Clocky, with this question. So Clocky wants us to do 2.2.4 in question 3. So this is how it looks like. Question 2, 2.2.4. 2.2.4 is basically this question over here. However, for us to able to understand 2.2.4 and answer it swiftly, we need to understand question 1 and question 2 and question 3 first. So that's what you're going to be doing in this video. So let's get into it. So question 1 says 2.2.2, an arithmetic and geometric sequence are combined to form a pattern, which is given by this is the pattern here. So it's a combination of arithmetic and geometric sequencing, right? And then 2.2.1 says write down the next two terms of the pattern. Okay, so how do you do this? So the next two terms of the pattern, you can see that the first term is x, and the third term is 2x, the fourth term is 3x. Therefore, will you agree with me if I say the third term of this pattern here, x, 2x, 3x, is going to be 4x. Okay, so this is the one here. And then if you look at this pattern here, this is 1 over 3, this is 1 over 9, this is 1 over 27. Essentially, this is 1 over 3, this is 1 over 3 power 2, that's 9. This is 1 over 3 power 3, that's 27. So therefore the next term is 1 over 3 power 4. So 3 power 4, that is 81. So the next term is 1 over 81. Okay, and then you get your 2 marks. Boom, boom. Right. So let's go to 2.2. So 2.2, determine the general term for the odd terms of this pattern. Write down your answers in terms of x. Okay, great. So the odd, so that's what they're saying here, for the odd term of this pattern. So the odd term of this pattern, so the odd numbers is 1, 3, 5. So that's the odd term. So the odd term, so in 2.2, so the odd term of this pattern is x, 2x, 3x. Okay, great. So that's the odd term of this pattern. So they want us to find the general term of this pattern. And first thing first, we are being told it's a combination of arithmetic and geometric. So let's find out if this is an arithmetic sequence or a geometric sequence, right? For you to do that, you know if it's a geometric sequence that the difference between these two terms, they should be equal. For example, 2x minus x is equal to 3x minus x, right? Because this is going to give you x and it's going to give you x. These are both equal. Therefore, this pattern is an arithmetic sequence, right? So we're using this term general formula, which is Tn is equal to a plus n minus 1 times d. And one can also imagine or see that this is not a geometric sequence. Why? Because in a geometric sequence, the difference, sort of the t2 over t1 should be equal to t3 over t2. In this case, it will be 2x over x should be equal to 3x over 2x. And this is going to be 2, this is going to be 3 over 2, and these two are not equal. Therefore, it's not a geometric sequence. It is an arithmetic sequence. Make sense? So that's how you differentiate the two. However, now we've discovered that is an arithmetic sequence. Therefore, a is your first term, and your first term in this case, the first term is x. A is the first term. So the first term is x plus n minus 1, and d, we've discovered that d is x. So this is x, d is x. And it's going to be x. If you simplify this, it's going to be n times x is nx, negative 1 times x is negative x, and x minus x is 0, so you end up with nx. So Tn is equal to Nx. Make sense? And this is just 2 marks. So I'll give you mark here, and I'll give you mark for that x here, for the dx. Okay, great. So that's 2 marks. Let me write this down here so you can remember. Okay, so that's the other pattern. Now, this petty, okay, let's go to 2.2.3. 2.2.3. Calculate the value of P26. 3 marks. Very tricky. Calculate the value of P26. Okay, so we have Pn, right? X. That is this P1, right? That's X. 1 over 3, that's P2. 2x, 1 over 9, 2x, 1 over 27. So this is P2, this is P3, this is P4, this is P5, this is P6. Do you agree? Great. So, however, they say P26. So they're looking at the even terms or the even sequency. And the even sequency is 1 over 3, 1 over 9, 1 over 27. Which, by the way, we have said is 1 over 3, 1 over 3 power 2, 1 over 3 power 3, 1 over 3 power 4. Okay, remember that's 1 over 3 power 4 that you said 1 over 81 earlier on. That's the even sequence, right? The odd sequence, that's what we just discovered here on 2.2.2. However, this is P26. So to find P26, and P26 is an even number, how do we do this? Please note this, you will do this way. So P26. So note this, these numbers here, that 1 over 3 is the second term. This is the second term. 1 over 3 power 2 is the fourth term, P4. 1 over 3 power 3 is the sixth term, P6. 1 over 3 power 4 is the eighth term. So would you agree with me if I say this is essentially equal to 1 over 3 power n over 2? Depending what is your n. For example, P2 is 1 over 3 power 2 over 2, which is 1 over 3. P4 is 1 over 3 power 4 over 2, which is 1 over 3 power 2. Great. P6 is 1 over 3 power 6 over 2, which is 1 power 3. I mean, you can already see that the pattern is true, right? 8 over 2, which is 1 over 3 power 4. So, would you agree with me that Pn is equal to, for the even numbers, by the way, is equal to 1 over 3 power n over 2 for even numbers. That's what Pn is equal to for even numbers. I want to stress that it's not the entire sequence, but for even numbers is 1 over 3 power n over 2. So, therefore, P26 is equal to 1 over 3 power 26 over 2, which is equal to 1 over 3 power 26 over 2. 26 over 2 is 13, because 13 times 2 is 26, right? 13. And that's your answer. I mean, you can simplify, take your calculator and patch 3 power 13, you get your answer, but that's your final answer. You can write it that way. So there's 3 marks. So P, this is equal to 1 over 3 power 13. And I mean, I will give you 3 marks for the answer, of course. And I'll give you 3 marks for discovering this. And I'll give you 3 marks for understanding the even pattern. 1 mark for understanding the even pattern. Great. If you have questions here, let me know. I'm happy to answer. Just comment on just give me a comment wherever you are, whether you're on TikTok or Facebook or YouTube. Just give me a comment and I'm able to answer back. Right, so let's go to, this is 3 marks, this is 2 marks. Let's go to the question that Chloe wanted to know. Okay, 2.2.4. So we're in this question. So let's go. 2.2.4. So now how do you answer this question? So we are saying, this is very distracting for me actually. The marks are very distractive. Let me just get out of the way. Right, great. So what do we do now? P here it says the sum of, so we're looking 2.2.4. so the sum of Pn is equal to 33.5. Determine the value of x. That's what you're looking for. Okay, so we are told that if you add this sequence over here, you get 33.5. If you add the sequence, you get 33.5. Okay, if you add this sequence, and we have already discovered one of the sequence, that the arithmetic sequence, that it is equal to, the odd one is equal to Tn is equal to nx, right? And the even one we did discover, but I mean I can show you again. 1/3, that's the even number. 1/9, the even term, because it's T2, T4, T4, T6. So this is 1/27. Now you can find this is a geometric sequence because r is equal to 1/9 divided by 1/3, which is equal to 1/3. Same applies as 1/27 divided by 1/9, it will give you 1/3. So r is 1/3, and this is a geometric sequence. So the geometric sequence Tn is equal to ar power n minus 1, right? And Tn, a in this case is 1/3 times r is 1/3 power n minus 1. And these are like terms, so we can just say 1/3, 1 plus n minus 1, which is equal to 1/3 power 1 minus 1 is 0, so power n, which could be written as 1/3 power n. And we've already discovered this, by the way, so we didn't have to do all of this. We already know this is equal to, remember this was 1/3, 1/3 power 2, 1/3 power 3, right? So it's 1/3 power n. So that's what we know. We know that the even number of this, the even sequence is 1/3 power n. Great, it's 1/3 power n. So we know that. So Tn is equal to 1/3 power n. So what I'm saying is the sum of these sequences is equal to the sum of the even number and the odd numbers. Sum of the even numbers and the odd numbers. And the odd numbers of this, we know that the odd numbers is an arithmetic sequence, and the even numbers is a geometric sequence. And in this case, the arithmetic sequence is nx, and the even sequence is 1/3 power n. Make sense? Do you see where we're getting an x plus 1/3 power n? If you don't, let me know. I'm happy to answer you down below in your questions. So this is still equal to 33.5. Okay, and this could be written as the sum of an x 31 plus 1/3 is equal to 31, equal to 33.5. Okay, and we know this we can easily simplify this, right? This is a geometric sequence, by the way. So n is equal to 131, 1/3 power n. It's a geometric sequence, and with a geometric sequence we have two options. We have two sequences. If you remember, with a geometric sequence we have the other one which says Sn is equal to a r power n minus 1 over r minus 1, or we have another one that says Sn is equal to a 1 minus r power n over 1 minus r. And you use the first one if r is greater than 1, and you use the second one if r is less than 1. And our r in this case is what? Our r in this case is r is equal to 1/3, and 1/3 is less than 1. So therefore we are going to use this formula. So this is equal to a 1 minus r power n over 1 minus r. And again, a is your first term of the even sequence, and the first term of the even sequence is 1 over 3. Remember the even sequence? 1 over 3, 1 over 9, 1 over 27. So that's the even sequence. So the first term is 1 over 3. So this is 1 over 3, 1 minus r, and r, again, remember we got that. R was 1 over 3 power n. Now I'm going to talk to you how to get n. This is 1 minus 1 over 3. So the way you get n is, let me rub this off. Let me know if you didn't understand here. I'm happy to clarify. But the way you get n, by the way, this n and this n are not the same. Not the same, right? The way you get this n here from the formula is, well, someone might say the same. It's debatable. But let me not go to the rabbit hole. The way you get this n is, you say, okay, great. You say n is equal to the last term, which is this, minus the first term, which is this one, plus 1. It's always the last term minus the first term plus 1. Always. The top term, this one, minus this thing here. If this is 2, it's going to be 31 minus 2 plus 1. If there was 3, it's 31 minus 3 plus 1. That's your n. So your n here is 31, but your n here could be what? What's the number? 30, right? Your n here could be 29. So please make sure you calculate your n correctly. It's very important. You might lose mark here. So this is 31. Your n is 31. So from here, you then say, okay, cool. My answer, let me just rub this 31. My answer is 1 over 3. 1 minus 1 over 3 power 31 over 1 minus 1 over 3. And then you get in your calculator, punch these numbers. If you punch these numbers in your calculator the way it is, you should get 0.5. If you don't get 0.5, let me know. If you get a different answer, let me know. Okay. So now we know that the sum of this is equal to 0.5. Now we need to find the sum of this. Great. How do we do this? Let me just copy this. Let's go to the second page. Let's paste it. So the way you find the sum of this, again, using, this is an arithmetic sequence. In this case, the arithmetic series, because you're adding the sequence, the arithmetic sequence, right? So with the arithmetic sequence, you have two options again. You have Sn series, arithmetic series. You have Sn is equal to n, a plus the last term over 2. Or you can choose this one, Sn n over 2, 2a plus n minus 1 times d, right? And you are using this one if you know the last term. So when the last term is known. If the last term is unknown, you choose this one. Okay, and in this case, we don't know our last term, right? Remember, the odd sequence, the arithmetic sequence was x plus 2x plus 3x, and we don't know the last term. It went all the way to infinity, so the last term is unknown, so we're going to choose this equation here. So therefore, this is equal to n over 2, 2a, n minus 1 times d. Great. Now, we've chosen a formula which you're going to use. Now we need to find n. Remember again, the way you find n, you say this term minus this term plus 1. So it's 31 minus 1 plus 1, which is equal to 31. That's our n. And d, we know our d from the formula that you've done d here. We already know what is d. D is x. If you don't know, go back and see that. Depending where you're looking at this, but I'm uploading the entire video on YouTube and Facebook and on TikTok. During the segment, just make sure the videos are too small, small for TikTok community. But if you want to see the entire video, because if you're seeing this in TikTok, you might see just a segment of this. But if you want to see the entire video, go to my YouTube or go to my Facebook page. Okay. So, okay, D is X, N is 31. Right, so we got 31 over 2. And your first term, this is your first term. This is T1, this is T2, this is T3. So your first term is X. So 2X, 31 minus 1 times D. D is X. So 31 divided by 2, that is 30 divided by 2 is 15. This is 15.5. Great. And 2x, 31 minus 1, that is 30. So you have 30x, 15.5. 2x plus 30x, that is 32x. Okay. And then 15.5 times 32. Let me bring my calculator. Okay, I don't need to. I don't need to do this by head. Man. There we go. There we go. That's how we want to do it. So 15.5 times 32, that is 496 times x. So the sum of all of these is equal to 496 times x. Now back again to what we have. So we know this copy should be equal to 33.5. And what do we know? We know that the sum of 31 n is equal to n. Okay, well, I don't have to rewrite that. N minus 1. We know that, where am I highlighter? So this is equal to that. So this is, therefore, this is equal to 496x. And we know this is 0.5. We got it from here. This is equal to that, 0.5. And it's equal to 33.5. Great. Now it's easy. So 496x is equal to 33.5 minus 0.5, which is 33. And x is equal to 33 over 496. Boom. And that's how you do it. Sorry for banging. I'm just excited. Thank you so much for this question. This is a very brilliant question, Kloche. Thank you so much for this question. And on the next video, I'll be just answering your question 3 again. Check that out again. And yeah, so if you got questions, let me know. Post it on your Facebook page. Post it on my TikTok account. Let me know on your YouTube. Write a comment if something that you don't understand, if something that you understand, if something that you want me to add, or something that you say something when you talk to me. Okay, talk to me right now. It's the time for you to write your exam and prepare for your exams. And if there's a person like me who's willing to help you for free to do well in your mathematics, you might as well grab that opportunity and use me. I'm here for you. I'm here to help you. I'm here to help you succeed. Thanks so much, Kloche, for this question again. And I'll see you on the next video. Boom.